Hello everyone, and welcome to the lesson. We're going to be having a look at exercise 6 and the solutions to these questions. Remember, these are all around and involving simultaneous equations. It's really beautiful maths that we do in this section. So let's have a look at our first question. We need to work out the first three terms. It says that the pattern is arithmetic, and that term 3 has a value of 23, and that term 26 has a value of 230. Okay, it tells you that the pattern is arithmetic. So, you know, term 1 is A, term 2 is A plus 2D, A plus D, term 3 is A plus 2D. All right, remember that the coefficient of D is 1 less than the position of the term. So the third term is A plus 2D. So what would the 26th term be? Good, A plus 25D. All right, remember, coefficient of D, 1 less than the position of the term. Now, I like to make A the subject of the formula here, since it has a coefficient of 1. And then it makes it really easy. We're just going to equate these two equations, all right? So we're going to let 23 minus 2D equal 230 minus 25D. All right, so what do we get? 23D will be equal to 207. Dividing both sides by 23, we get that D will be 9. Amazing. Okay, so we know what our constant difference is. And all I'm going to do now, I'm going to take this and I can sub it back into either one of your equations, right? It doesn't matter if you do it in equation 1 or 2. Let's just do it in equation 1. So A will be equal to 23 minus 2 times 9. So that's going to be 23 minus 18. So your A value will be 5. Term 1 is 5. So the question says, what are the first three terms? So it's going to be 5. 5 plus 9, your constant difference, 14. 14 plus 9, what's that? 23. And so the pattern goes. Amazing. They told us that term 3 was 23. So we know that we're right. Hooray. That was pretty easy. Let's have a look at the next one. All right, so in 1B, so this is going to be exactly the same, right, grade 11s. The fifth term is 19. So term 5 is 19. And, term 5 is 19. And the 15th term, term 15, is 59. Okay. Calculate the first three terms. So we're first going to rewrite term 5 as, you guessed it, A plus 4D equals 19. Remember, the coefficient of D is 1 less than the position of the term. So term 5 will be 4D. Term 15, therefore, will be A plus 14D is equal to 59. I'll make A the subject of the formula. 59 minus 14D. All right, and there's my second equation. We now let the two equations equal each other. So 19 minus 4D is equal to 59 minus 14D. And let's solve. So 10D will be equal to 40. So our constant difference is 4. Awesome. Now we're going to sub either back into equation 1 or 2. It doesn't matter. So I'm going to sub it into equation 1. Now we know that D is equal to 4. So A is going to be 19 minus 4 times 4. So 19 minus 16. So A is 3. So your pattern is going 3. Constant difference is 4. So we add 4. And so we go. Cool. Do you see how nice and quick these questions actually are? But they're worth quite a few marks in a test or an exam. It was always so awesome when we know we're going to get some good marks for our hard work. Okay, let's jump into question 2. Right, in question 2, pretty much same. It says the 15th and 3rd term. Okay, so the 15th term is 100, and the 3rd term is 28. Determine the 100th term. Okay, so a little bit different from the previous ones, but not really, to be honest. So we're going to have A plus 14D equals 100. So A is 100 minus 14D, number 1. All right, and then A plus 2D is equal to 28. So A is equal to 28 minus 2D. That's my second equation. Let the 2 equal. 100 minus 14D is equal to 28 minus 2D. All right, let's go. Negative 12D is equal to negative 72, right? Divide both sides by negative 12. Your constant difference is a 6. We need to figure out term 1. So just find A. My D's and my A's kind of look similar, sorry. So now we're going to sub D into either equation 1 or 2. Doesn't matter. Right, so A is going to be equal to 100 minus 14 times 6. So it's going to be 84, hey? So A is going to be 16. So now how this question differs is they ask you not for the first 3 terms, but for the 100th term. So please, let's not just manually add 6 from 16 100 times. That would be terrible, right? We want to determine the general term for this pattern. So remember, it's Tn equals A plus n minus 1 times your constant difference. So let's just adjust this now for the question. So it's saying we want to find the 100th term. Term 1a is 16 plus 100 minus 1 times my constant difference, 6. So term 100 is going to be 99 times 6 plus 16. So that's going to be 610. Right. It's pretty easy, hey? We're cruising. Let's have a look at question 3. All right, so in question 3, the 13th and 7th terms of an arithmetic sequence are 15 and 51 respectively, which I have over there. Which term is equal to negative 21? Okay, so we need to get the general term again first. So A plus 12D equals 15. So A will be 15 minus 12D. And for term 7, A plus 60 is equal to 51. So A is equal to 51 minus 60. All right, remember coefficient of D, 1 less than the position of the term. We let the two equations now equal. So 15 minus 2D is equal to 51 minus 60. So 4D will be equal to 36. So our constant difference will be 9, right? Divide both sides by 4. To find A, we sub back into either equation 1 or 2, doesn't matter. I'm subbing it into, that's my first equation. My second equation, I'm subbing it into my first one. So therefore, what will our first term be? That will be negative 93. Okay, so that's lovely. We've got the first term, we know our constant difference. The question asks, though, which term is equal to negative 21? Okay, so watch how I go about this. This is the general term for all arithmetic sequences, right? Let's fill in stuff now that we know. All right, so we know that the value of term 1 is negative 93 and that the constant difference is 9. This question asked, what is the value of term, or which term is equal to negative 21? So the value of the term is negative 21. You are trying to solve for n. Which term? Okay, and now we just go about rearranging this so that we can solve for n. So I'm going to add 93 onto both sides. So negative 21 plus 93 is 72. I'm going to expand that bracket, right? So we're going to have 81 is equal to 9n. Divide both sides by 9. All right, so the 9th term is equal to negative 21. Okay, cool. This is super basic. So that was 3a. 3b says, show that 66 is not a term in the sequence. Okay, so we're not going to panic. We're not going to think now, what we're going to do is, so we know the nth term from before, right? You just did it for me. You said that Tn is equal to a plus n minus 1 times d. All right, knowing that a is negative 99 and d is 9. So now it says, it's vanished. Where's it gone? There we go. Show that 66 is not a term. So we're going to let the value be 66. So actually what we are doing, it's the same as in the previous question. We're solving for n, but what's going to happen is that your n is not going to be, it's not going to be a nice, like, juicy whole number, right? Which you want the position of your terms to be whole numbers generally, right? So we just need to solve for n now. I'm going to carry on over here. So I need to add 93 to both sides and the 9. So I'm going to get 168 is equal to 9n. And when you divide both sides by 9, you get that n is 56 over 3, or 18,66 recurring. So let's say 18,67. So you've got term 1, term 2, term 3. You don't have term 18,67. So therefore, right, we know that 66 is not a term in the sequence. All right, we want those ends to fall onto nice whole numbers. Okay, so that's question 3. Let's have a look at our next question. All right, so let's look at question 4. Term 7 is negative 4. So we know that that's just a plus 60 equals negative 4. All right, so let's now be careful with this next bit. So it says S16 is 24. That is saying you are summing the first 16 terms, so you're adding them together and getting 24. So I'm just going to start off with the general term for summing an arithmetic series. All right, that's what the general term is. Now let's just fill in information that they've given us. So we know that when we sum the 16 terms, we get 24. So we know that Sn will be 24, because that's what it adds up to. N is 16. Okay, so now we're just going to simplify here so that we can get this equation, which we can equate with this first one. Okay, sorry. So we're going to have 24 is equal to 8, 2a plus 15d. I'm going to divide by 8 on both sides. 3 is equal to 2a plus 15d. Okay, so do you see now that here I've got a coefficient bigger than 1 in front of a? So it's not as simple as the previous ones where a had a coefficient of 1. So we could just make a the subject of the formula and go. We're still going to make a the subject of the formula for both. So this is going to be a equals negative 4 minus 6d. That is my first equation. For this one, so do you see, I know you're not going to like that we're going to work with fractions, but it's the way it is. Sometimes we got to embrace the fractions, guys. Okay, so to make a the subject of the formula, it's going to be 3 over 2 minus 15 over 2d. That will be a. So there's my second equation. All right, so we're going to let these two equations equate. We're going to let them equal each other. So negative 4 minus 6d is equal to 3 over 2 minus 15 over 2d. Okay, so to get rid of these 2's in the denominator, I'm going to multiply every term by 2. So then I'm not going to work with fractions anymore. So negative 4 times 2 is negative 8. 6 times 2, that will give me negative 12. So this would then just be 3, and that will be 15, right? Because those both these terms have 2 in the denominator. So when I multiply through by 2, they fall away, right? Or they can't get cancelled out. So now I'm working with nice whole juicy numbers. I get that 3d is equal to 11. So d is 11 over 3. And I'm pretty sure that if you get an answer of your constant difference being 11 over 3, you think perhaps you've gone wrong somewhere. But back yourself, keep going. Let's see. What did they want us to find? The first term and the constant difference. So we found d. To solve for a, I'm actually going to come back up here. So a will be negative 4 minus 6 times 11 over 3. So let's see what term 1 will be. So it's going to be negative 4 minus, that will become 2. So term 1 is negative 26. So actually now your constant difference being 11 over 3 doesn't look so bad. And if you actually test this, so remember, you could actually figure out now, so is term 7 equal to negative 4? So you could check your answer to see if you're correct. But we know that you're correct because you're super smart. Let's jump into 4b. So in 4b, what do they say? They say that the fifth term is 0 and the 13th term is 12. They want you to find the sum of the first 21 terms. Okay, so let's deal with these first two concepts first. So a plus 4d equals 0. So a will be negative 4d. That's going to be your first equation. A plus 12d, the 13th term is 12. So a will be 12 minus 12d. Right, that's your second equation. So at this point, I'm literally just going through the motions, right? This is what we've now practiced several times. This finding d first by making a the subject of the formula. We get that 8d is equal to 12. So d is going to be 12 over 8, which is 3 over 2. I'm then going to sub back into here so that I can find a. So a is negative 4 times by 1.5. So that's going to be negative 6. Okay, so we've got the value of a and d. The question, however, said, find the sum of the first 21 terms. So S21, the sum of the first 21 terms is n over 2. So we know n is 21. 2a plus n minus 1 times d, the constant difference, 1.5. Okay, and now we're just going to simplify all of this. So I like to sort out everything in the bracket first. So this is going to be negative 12 plus 20 times 1.5, which is 30. So it's going to be 21 over 2 times by 18. All right, so therefore S21, so that would be 189. Okay, cool. And that would be our final answer. So you see, we actually got quite a bit of work happening here. And this question would be worth a good amount of marks, but it's really quite straightforward. Cool. Next one. All right, so in this question, they say the first term is 6. So I'll literally just say a equals 6. I know the value of a, right? Remember, term 1 doesn't have a constant difference. It's just a. The sum of the first 5 terms, so if I add them 6 plus the next 4 terms, I get to 250. The question is to calculate the 12th term. So we've already got this a equals 6. So I just need to work around this over here. So remember again, it's Sn is equal to n over 2, 2a plus n minus 1 times d. All right, and all we're going to do now is sub in the information that you do know. So I know that Sn, when I sum the 5 terms, I get 250. So Sn is 250 and n is 5. 2a, well, don't we actually already know what a is? We know it from over here. So let's actually just sub it in already. 2a plus n, so we know there was 5 terms. I don't know the constant difference. So in this question, they've actually given you a. It's d, the constant difference that we are trying to find. And then once I have that, I can create the general term for this pattern and work out term 12. But let's get back to this one over here. So 250 is equal to 5 over 2, 12 plus 4d. I'm going to multiply both sides by 2. So 500 is equal to 5. Well, yeah, okay, let's just do. So I'm doing quite a few steps here. Don't have to do as many. And I'm going to divide. So I mean, over here, I could have just divided both sides by 5 over 2. Same though, hey? I'm not going to divide by 5, and I get that 100 is equal to 12 plus 4d. So now I can just solve for d. 88 is equal to 4d. So divide both sides by 4. So your constant difference is 22. Cool. So your pattern is going 6, 28. Then we add 22 again, 50, right? That's what the pattern is looking like. The question said we need to calculate term 12. So, I mean, we can just keep adding 22, but I'm just going to calculate the general term then for this pattern. So, Tn is equal to a plus n minus 1 times d. So, to figure out term 12, we're just going to sub 12 into n. All right. So therefore, term 12 is going to be, so that's going to be 11 times 22 plus 6. So term 12 will be 248. Okay, so you could just keep, at this point, keep adding 22 and do it 12 times. I feel like this is quicker, right? So that should be our final answer for 4C, 248. Okay, question 5 is a really lovely question. It says the first and last term of an arithmetic series is 5 and 61. Okay, so I'm going to work with this formula. So Sn is equal to n over 2a plus l, right? Where a is obviously the first term, and L is your last term. So this summing formula for an arithmetic series, you can use this formula here if you've been given the first and last term, as we have been in this question. This question says that the first term is 5 and the last term is 61. So I can put into A, right? A, first term is 5 and the last term is 61. It says if we sum all the terms, we get 957. Determine the number of terms. So we're actually going to solve for n. When you sum all the terms, you get 957. Okay, so yeah, this is it. It's actually a pretty easy one to solve, right? We're just going to multiply both sides by 2 so that we get rid of that 2 in the denominator. This is going to be n times 66. So this is just going to become 66n. And now we simply divide both sides by 66. And your answer is 29. Cool. So, yeah, that's that. That was quite an easy question, hey? So, do you see using this formula here is easy? You can, however, always use this big long guy, right? In all situations, you can always use this formula, but actually, in this instance, way quicker. You can always use this one as long as you have the first and last term, which they did give to us in this question. All right. Cool. Let's jump into question 6. All right. So question 6 is a little bit different to our previous ones. It says that the sum of the first 10 terms is 145. Okay. Let's just deal with this first. So Sn is n over 2, 2a plus n minus 1 times d. All right. We know that we're summing 10 terms, and then when we sum them, we get 145. So it's going to be 2a plus 10 minus 1 times d. I'm going to divide both sides by 5. 10 divided by 2 is 5. So we're going to go 2a plus 9d. Okay, so I'm actually going to stop for now. Well, I mean, we can make a the subject of the formula, but let's just hold up here for now, because we've got to deal with this other information. I'm just going to draw a margin. So the other piece of information says the sum of its fourth. So we're adding these terms. The sum of the fourth and ninth term is 5 times the third term. Okay, so how do we write term 4? It's a plus 3d. How do we write term 9? It's a plus 8d is equal to 5 times a plus 2d, right? Remember, the coefficient of d is always 1 less than the position of the term. So let's just simplify each side now. So 2a plus 11d is equal to 5a plus 10d. All right, so I'm just going to now decide what do I want to make the subject of the formula. I guess we've been working with making a the subject of the formula. We can just keep doing that. So if I put the d's, I'm going to put the d's on this side. Oh, but look at that. Actually, I make a coefficient of 1 for d if I simplify like that. So let's make d the subject of the formula then over here. So I'm going to have 29 minus 2a is equal to 9d. So 29 over 9 minus 2 over 9a is equal to d. Okay, so I know you're really not going to like these fractions, but we're cool, doesn't matter. We're going to let the two equations equal. So 29 over 9 minus 2 over 9a is equal to 3a. So remember that if your denominators are the same, you can just multiply through. You can just multiply through by that number. And then this will just become 29 and negative 2a. We're just going to multiply 3 by 9, which is 27a. So we get that 29 is equal to 29a. My word, so a is 1. That's great. So we've calculated the first term. We just need to get the constant difference. So I'm going to go back up here. The constant difference will be 3 times 1. So your constant difference will be 3. All right, amazing. So here's our answers. Constant difference is 3, and term 1 is equal to 1. Okay, wonderful, cool. So this question was a little bit different because of this whole situation. But actually we're just drawing on those very basic ideas from before, and then quite a manageable question actually. Hey, all right, next one. All right, so in this question, they've given us this pattern, 1 plus 2 plus 3 plus 5 up till plus n. We can see that we are consecutively adding 1 each time, right? So we know that A is equal to 1 and that there's a constant difference of 1. The first question says you need to show that Sn is equal to n plus 1 over 2. So basically they're saying show that that is the general term for this pattern if you are summing. So remember now we have those two formula. We've got the n over 2 a plus l, right? Remember that's when you know the first and last term, and you also have this longer formula. So the longer formula you can always use, right? Whether you know the last term or not. But since they've given us the last term in this question, I think I'm going to focus and use this formula instead. So Sn is equal to n over 2. A is term 1, which is 1, plus L, the last term, which is n. And if you look at how they've written it, so the way that they've written it is they put that n in front, they just switch these two terms in the bracket, and they make everything over 2. All right, so even if you stopped at this point, you would be correct. Okay. Right, so in 7b, it says, find the sum of the first 1001 terms, excluding all multiples of 7. What a beautiful question. All right, so let's just start off first with the S1001. So I'm literally just subbing in to the formula above that we just determined, right? And it's basically 1001 times 1002 divided by 2, which is 501,501. We need to deal with this information about excluding all multiples of 7. So just think about what the multiples of 7 pattern would be. It would be 7 plus 14 plus 21 plus 28, right? It would just be summing all those multiples of 7, and we're just going to subtract it from that answer we got above. So if this was the pattern, 7 plus 14 plus 21 plus 28, all right, A, your first term would be 7. Obviously, multiple 7s, your constant difference would be 7. So we are just going to pop this into the sum formula, but let's just figure out how many multiples of 7 are there in 1001 terms. So if I go 1001 and I divide it by 7, I get 143. Okay, so we're now going to say S143 is equal to 143 over 2, 2a plus n minus 1 times d. Okay, so if I just explain this again, this is now, maybe I should just put it, let's just put in a block. So they're saying we need to exclude, this is excluding multiples of 7. All right, so multiples of 7 would obviously go 7, 14, 21, 28. So in this pattern, the first term is 7, the constant difference is 7, and the multiples of 7 in the first 1001 terms, right? There are 143 multiples of 7. So I'm just working out what those terms would add up to, and then I'm going to subtract it from the 501,000 that we had before. All right, so if I work this out, that is 72,072. All right, so your final answer is, it's going to be 501,501 minus the 72,072, and we get an answer of 429,429. Okay, so yeah, definitely a more difficult question, but a really beautiful question. Yeah, I hope that makes sense. So in the end, we subtracted those two, and we got to our answer of 429,429. Okay, let's jump into question 8. So from question 8, it's really nice. We're going to start looking at geometric number patterns. Okay, determine the first 3 terms of each of the following. Okay, so term 6 is 28. So term 6 equals 28, and term 11 equals 896. Okay, so remember, now we're doing geometric progressions, right? Not arithmetic. So term 6 we could rewrite as a times r to the power of 5 is equal to 28, and term 11 is a times r to the power of 10. So when it's the geometric patterns, remember the exponent is 1 less than the position. Then what you do from here to solve for a and r is we're going to divide the two equations. So I usually like putting the equation, or the bigger exponent I like having as the first term. So we're going to have a r to the power of 10 equals 896, and then a r to the 5 equals 28. Remember what you do, you divide these two, because then what happens is the a's cancel each other out, and you're going to say r to the 10 divided by r to the 5 is r to the power of 5. Then we work out what is 896 divided by 28. That is 32. So now what you're going to do is you're going to find the fifth root on each side. And the fifth root of 32 is just simply 2. All right. So our constant ratio is 2. We need to find the first three terms. So we need to figure out a. So a times r to the power of 5 gave me 28. So a is going to be 28 divided by 32. So therefore a is going to be 7/8. All right. So therefore our pattern is going, remember we've got to do the first three terms. So term 1 is 7/8. Term 2 is going to be 7/8 times your constant ratio 2. So that's going to be 7/4. Term 3 will be, so remember we're multiplying by 2 each time. So now we're going to multiply by 2 again, and that will be 7/2. Awesome. Right, so those are our first three terms. Let's have a look at B. All right, so in 8b, they say that term 2 is 3. So AR is equal to 3, right? That's term 2. And the fourth term, so AR cubed, is equal to 6 3/4. So I think I'm going to rewrite that as an improper fraction, 27/4. Okay, so to solve this now, I put the term with the bigger exponent is what I put on top, because we're dividing, and I don't really want to work with negative. I don't want to work with negative exponents. I mean, you can, no problem. All right, so when I divide, the a's cancel out, and you're left with r squared, right? R cubed divided by r. If we do 27/4 divided by 3, that's the same as 27/4 times a third. So that's going to be 9/4. Right, and if we square root this, so just be careful. When you square root, remember you're actually getting plus or minus the solution. They didn't tell us here that r must be positive or negative. So I think we actually just need to work out the pattern using both values for r. Remember, when you square root or find the fourth root, when your exponent is even, you get plus or minus your solution, hey? So we need to just find a. So realizing now you're going to get two solutions for a. So I'm going to just work from here. So a, when your constant ratio is positive 1.5, right, I get that a is equal to 2. Or when your constant ratio is negative 1.5, we get that a is equal to -2. All right, so we're actually going to form two patterns here, grade 11s. The one pattern is going to go to, so then we multiply by the constant ratio, 3/2, and we keep going. So this will be the one pattern. So this is when a equals 2 and r is 3/2. All right. then the other pattern that you will form is when a is negative 2, all right? So then it's going to be negative 2 times negative 1.5. That will give me 3, 9/2. Okay, so this pattern is when a is minus 2 and r is minus 3/2. All right, so just be careful. Because the exponent was even, we get the 2 solutions, right, for your constant ratio r. Okay, cool. Let's go. Question 9. If you are still here and still listening, I'm very impressed with you. All right, the 9th term, so ar to the power of 8. The 9th term is equal to 80, and the 6th term, so ar to the power of 5, is equal to 10. All right, the first question is find the first term and the constant ratio, and then find the number of terms if the last term is 5120. Okay, so we're going to go AR8 equals 80. We're going to divide that by AR to the power of 5 is 10. All right, so when you divide the two, the A's cancel out. R to the 8 divided by R to the 5 is R cubed. And 80 divided by 10 is 8. If we cube root both sides, we get that the constant ratio is 2. So to determine A, 2 to the power of 5 is equal to 10. So that's going to be 10 divided by 32. So your first term is going to be 5/16. All right, okay. So we've already, wrapped up this question. Let's see what they want in B. They said how many terms if the last term is 5120. So let's just come up with the nth term for this pattern. Tn is equal to A 5/16 times R 2 to the power of n minus 1. All right, so that's the general term for this pattern. They said that the last term, so the value of the last term is 5120. All right, so now we're just going to solve for n. Okay, so we're going to divide 5120, we're going to divide that by 5/16, and we get 16384, and that's equal to the power of n minus 1. So that is the same as 2 to the power of 14. Remember here you can use logs at this point as well. So 14 is equal to n minus 1. So your answer is 15 terms. Yep. Okay, great. So this one wasn't so bad. Oh, we've only got a few more questions left to do. Okay, we're nearly there, guys. Okay, in question 10, right, so I'm just going to start straight away. Term 6 is AR5. They say that the value of term 6 is 5/18. We're going to divide that by the value of the third term, so AR squared, always one less in the exponent than the position, so term 3, AR squared, 15/16. All right, so we're going to divide these two. The A's cancel out, you're left with R cubed. You need to figure out what is 5/18 divided by 15/16, and that is 8/27. All right. If you cube root here, so cube root the numerator, and you cube root the denominator. All right, so 2/3 as my constant ratio. That's looking good. We need to find the value of A. So AR squared gave me 15/16. So therefore A is going to be, we're going to say 15/16, and we're going to divide it by 2/3 squared, and that is 135/64. Okay, so what is the general term? What is the nth term for this pattern? It would be Tn equals A 135/64 times R 2/3 to the power of n minus 1. Now we actually still need to finish this question. The question was, how many terms are there if the last term, okay, so the last term, which we don't know where it is equal to 40 over 729. So that's the value of the term. So we're going to sub that into there and solve for n. All right. So I'm going to keep working here on the right side. So 40 over 729 is equal to term 1 times by your constant ratio to the power of n minus 1. Now, if we divide both sides by a, the 135 over 64, we get 512 over 19,683. Okay. So this is looking like a real mess, right? And remember from this point, we can use logs. Maybe we should use logs, or we can rewrite it like this. So 512 as a product of its prime factors is 2 to the power of 9. And the 19,683, that is 3 to the power of 9. So let me just show you. So we can rewrite this side actually like this. Since both their exponents are to the power of 9, right? If you're thinking about your exponent laws, you can rewrite it like that. So therefore, n minus 1 is equal to 9. So there are 10 terms. Hooray! Remember, at this point, you really could just jump straight into logs. If you don't want to do this whole story here, we still arrive at the same solution, right? That there are 10 terms. Okay, 2 more questions. All right, 11. In a geometric sequence, term 6, so AR5, is negative 243, and term 3, AR squared, is equal to 72. First question says, determine the constant ratio. So we know that we're going to divide. That's going to be r cubed is equal to negative. So we do 243 divided by 72. And we get 27 over 8. Right, so r is going to be negative 3 over 2. Okay, perfect. So that was for A, part 1. Okay, so this was part 1 of 11A. Part 2 says the sum of the first 10 terms. So Sn is equal to A, r to the n minus 1 over r minus 1, right? That's how we sum a geometric series. Looking back at part 1 of this question, let's figure out what A is. So A, negative 3 over 2 to the power of 2 is equal to 72. So A is going to be 72 divided by, it's going to be 9 over 4, hey? Let me square that. So we get that A is equal to 32. So now we can go here. S10 is equal to 32. So R was negative 3 over 2 to the power of 10 minus 1 over R minus 1. All right. And we can just smash this all into our calculator. And we get an answer of negative 11,605 over 16. If you wrote that as a decimal, it would be negative 725,31. All right, so whether you use it as a fraction or round it off to 2 decimals, that would be your answer. All right, so that was for 11A. 11B, okay, well, this seems to be a completely separate question. I thought maybe they'd be linked. All right, so in 11B, it says the constant ratio is negative half. Okay, so R is a negative half. The 8th term of the same sequence is negative 5 over 32. Okay, so the 8th term, so AR7, is negative 5 over 32. Determine the sum of the first 8 terms. Okay, well, we already know what R is, so we can figure out A. We're just simply going to substitute negative half into r from what we have above. All right, so we get that a is going to be 20. That's nice. All right, so now I have a and I have r, and the question is to sum the first 8 terms. Okay, so I'm going to finish that off on the side here. So let's just make space. Let's just go underneath. Okay. All right, so what are we summing? The first 8 terms. So S8 is equal to A, 20, R to the N, so they said 8 terms, minus 1, over R minus 1. Right, and we just punch this all into our calculator, and we get an answer of 425 over 32. Amazing. Well done, guys. This was a really lovely exercise with some beautiful questions, and I hope you enjoyed it, and I want you to know that you are a superstar. Well done.